see. We've got the make the inference.
Make the inferences.
Take actions.
Yeah. So this is group 7. I was gonna ask you guys.
You got 100 on the project thingy on the describe the data.
Yay!
Nice. Good job, Eduardo.
Hey, I was gonna ask you, Edward. Can you send me the graphs and stuff? Because I'm assuming all that needs to be into the PowerPoint, right?
Yeah, you're gonna need all that.
Yeah, I'll send it to you.
Thank you.
Yep.
Yep. Yeah, and the one question before what I'll do is it says title of the assignment, name, research question, which we've all gone over 5 million times, right? The hypothesis test we chose to use, which was ANOVA. And then in the paragraph, they want to know whether or not our data meets or fails to meet the requirement for your hypothesis test. And then I can use the QQ plots to show that. And then formulas or whatever. And then it has a state the null and alternative hypothesis, which is all the means are equal or at least one mean differs. But one thing we have to decide as a group is our alpha level, our level of significance.
Why don't we just do 0.05, which is what most of them do?
Isn't that like the common or the?
Well, it can go anywhere from 0.01 to 0.1.
Yeah, 0.05 some more. That's a 95% confidence interval. So,
well, I doubt it's that.
Yeah.
Well, I wonder if we lowered the. Or isn't it the opposite? If we lower it, then we're more likely not going to.
Well, if you lower it, you have a greater chance of getting a type 1 error, or a smaller chance, but you also have a smaller chance, greater chance of not rejecting it.
Yeah.
Wouldn't you, if you lowered it to a 0.01?
Yeah.
Oh no, it would be even smaller than the 0.5. So.
Yeah. Yeah, I'm good with whatever. I'm okay with 0.05 if we want to do 0.1 or 0.01.
It can go to 0.001 to 0.1 is what a confidence interval can go from.
Yeah.
So I just leave it at 0.05.
I think it's just easier.
Yeah, let's just leave it at 0.05. Okay. Very cool. I'll do that. Then what I'll do is I'll go ahead and write it up and send you guys a copy tomorrow or Thursday morning, and you guys can look at it and see if you're good with it, and then, or if there's any changes that you want to make, and then we can meet Thursday night and discuss it and then send it in. So.
All right. Sounds good.
All right. Very cool. All right, let's start this thing. Let's look at the preparation. Wants us to open up the gharial crocodile data.
No more.
I know. I have it out. Let's see. Okay. So it says check the 5 assumptions for conducting a linear regression data. List the 5 assumptions below and explain how you check the assumption. Include charts and graphs where appropriate. Let's see, I could share a screen, or you guys just want to do it on yours? It doesn't matter to me.
Oh, see, I'm trying to open it again I get that same error. I'm gonna go through.
Really?
I'm gonna go through the data file again.
Yeah.
Thank goodness you showed me how to do that. That was weird.
Click Control when you click on it, and it'll straighten it out.
Okay, so the first test is that to check whether or not it's linear, and so we you can run go to graphs scatterer dot define, and then put in the y-axis the body length and x-axis the head length. Okay. It's just showing one right here. And you could put the line through it, see if it's hot dog shape. That's what we're looking for. All right. So mine looks like it's hot dog shape. So it's, and then you do the same thing. Whoops, graphs, legacy dialogues, scatter dot, define. But instead of the y-axis, you put in the unstandardized residuals.
And that one you don't want any.
Yeah, you want to make sure there are no patterns.
There shouldn't be any pattern there.
Yeah. So there's that one, and it looks like it. So we meet the first test, or yeah, first assumption. And then for the normal error term, we run a descriptive statistics with the QQ plots. So you just put in the dependent list, the unstandardized residual, go to plots, click on normality plots with test, hit continue, and OK. And should give us, there's our QQ plot. And it also looks normal. So we have a normal error term. And then we can actually go back up to that residual scatter plot and check if it doesn't look like a megaphone for the constant variance. And it doesn't. So we would meet that requirement. And the other two, we just assume that we meet.
Right, we can't check those at all.
Yeah. So, all right, so it looks like we meet our requirements. So they want us to state the null and alternative hypothesis. So who has that?
The null is beta 1 is equal to 0, and the alternative is beta 1 is not equal to 0.
Yeah. Awesome.
Which your answer plot, the answer thing in the book says beta 1 is equal to 0 and beta 2 is not equal to 0.
Oh, funny.
But it's beta 1 on both of them.
Right, you're like, thanks a lot.
I'm just kind of giving up on them.
Check your answers.
Exactly. Okay, so then it says to run a test, we do, well, you kind of, I'm just trying to make sure I've got it right. So you go up to the, let's see, save plots. I'm trying to like remember on this one. Do you do this? So you go to analyze, regression, and then linear.
Right.
And you, so first to find our test statistic. Yeah.
It's under the coefficient.
Okay, good. Yeah, the coefficient box. Do you have that?
It's 22.675.
Okay.
Because we want it on the bottom line and not the top line.
Yeah.
So we always want the bottom one.
I know. I have to remember that. Bottom line, bottom line. And then our degrees of freedom you find up in the ANOVA box under the residual. Is that right? I just want to double check. Yeah.
Yes.
Which is 15. The p-value, where do we find that p-value?
It's over here again under the coefficients. It comes close to 0.
On the head length, yeah.
So it's on the bottom line under sig.
Yeah. It's like, yeah. It's one of those big 0 numbers. And in order to make sure on your test that you had that confidence interval when you went in and did that linear regression linear, you just go to statistics and click on confidence interval, and you'll find that next to, on that same spot that Chris was showing us in the coefficients box on the bottom line under head length. 6.704 is our lower bound and 8.096 is our upper bound. And then the conclusion before we have sufficient evidence to suggest that there is a linear relationship between head length and body length on gharial crocodiles.
And if zero's in it, then we have sufficient evidence that there's not a linear relation.
Yeah.
That's just another way you can check that.
I know. All right. Well, any thoughts or questions? Are we ready to plunge in and take our quiz? Let's see.
Well, I'm still not clear why we have to have a beta when everything we're doing is a B.
I know, because they just like to give us everything.
Well, I don't want everything.
To be prepared.
I know.
I only
That's
want what
right.
I have to answer it. Don't throw in any extras.
Right.
Confuses me.
Right. Exactly. I'm with you. I'm like, so why? Oh, yeah. That was always the most confusing part. Okay. I think I'm finally in my quiz.
All right.
Okay. So answers 1 and 2. Easy
Dang,
peasy.
18.
18.
Yeah.
Okay, so we need to open up the math. That's right.
And we can't use the
And
same crocodile. We have to use the other crocodile.
Of course.
So we have to open them
Well,
both
we
up.
already had that data.
All right. Take 5 minutes to get those open. Hey, Chris, the first question talks about the true linear regression equation.
Yeah, I know.
Although it doesn't show, maybe that error of terms is only what we run. It's there because they're showing this true linear regression. They don't have the epsilon on it. So maybe it's to just if you're running.
So the epsilon only goes in there if you're running like just B1 plus BX?
Well, I'm wondering if it's just used when you run a hypothesis test.
Oh, could be.
I don't know. And then we don't have to calculate it by hand because it's too much. But oh, excuse me.
All right.
Okay.
Well, the answer is C.
Okay. Sorry, I've got too many files open. I'm gonna knock some of them out. Okay. Okay. So I'm here now. My file's finally open. Okay, the true linear regression equation y equals beta naught and beta 1 times x equal, we're known. What is the known alternative? And you said it was C. You are correct.
Yeah, it's the only one it can be. That's the only one that's there.
Yeah. Yeah, because there is no greater than or less than. It's either equal to or it's not.
Uh-huh.
It's either a linear equation or it's not one. That's all that says.
Yeah. Yeah. All right. So then number 4 says a residual is, I think it's C. Yeah, I think it's C. It's the difference between the observed y and the predicted. I like the answer D, though. It makes more sense.
It's what's left over.
That's right.
Yeah.
That's what the word residual means.
Exactly. Sounds like real English to me.
Yeah, it's
Okay.
what's left over.
That's probably why they put it in there. Trick people.
Right.
And we're going, hooray, there's real English. We ought to know it's not right.
All right. Exactly. That's funny. All right. Question 5. A plot of residuals supports using linear regression when the residuals look normally distributed, the residuals are all positive, you see a megaphone shape in the residuals, or you see a pattern in the residuals.
Well, since you don't want C and D, those are knots, and your residuals
Right.
are not all positive. It's got to be the top one.
Yeah. All right. Should we say A just for fun?
Well, I don't know if you can
Okay.
have residuals that are negative.
You know, I don't remember.
I don't remember it.
Well,
saying
let's
anything.
guessing that.
It says residuals are an
either.
observation is defined as the difference between the observed value y and the value that would have been predicted. It is tedious to calculate, but here we're going to show you how to do it.
Yes.
I'm trying to remember where I read this. It's hard.
Well, you don't want a megaphone. That's what you don't want. And you don't want to see a pattern in the residuals.
Right.
But I don't know if they're if they can be positive or negative. I think they can be negative. They're on both sides of the line.
Right. Whoa. Yeah, they could be
QQ plot.
negative.
Oh, don't yawn. That's contagious.
I know, because y can be negative, and it's the difference between observed and
predicted.
And you can have predicteds that are negative.
Residual plot. No, what we hope to see. No pattern.
Right.
Yeah.
So
I'm
like
with
Chris
you.
said-
I'm guessing A. Go ahead. Sorry.
No, I was just saying, just like Chris said. So, well, we get a second chance. See, that's what's nice.
That's right.
You can narrow it down to 2. You're like, oh, I get it wrong. It's the next one.
Yeah. My nursing ones don't give you a second chance. It's either all or nothing.
Well, this class didn't used to. I'm very grateful.
Well, I'm glad they changed it.
Yeah.
Me too.
Me too.
But there have been a few nights where the second chance has not helped.
Yeah, that's true too.
That's true. It's true. Oh, it's
You
so
know, like
funny.
I really don't know what I'm doing then.
Yeah. Okay. All right. So 6. For the next 8 problems, use the data and math. I keep saying math. It's math as self-efficacy. Use confidence variable as at the explanatory. So that's X. Confidence variable is X, and score variable is response variable. Compute residuals for the data using software. What statement best describes the residuals? Okay. Well, so math self-efficacy. This is where you go to analyze, right? And regression
Linear.
and linear. And we want the dependent to be confidence rating, right? No, I lied. It's not.
It's scores.
That's independent. Score is, yeah. And then you go to save. And you click on residuals, and unstandardized residuals. Let's see if, okay, I was gonna see if we could. I'm gonna go into statistics and go ahead and hit the confidence intervals just in case they ask us. I wonder if they'll let us print plots from here. No. I'm not gonna mess up. Okay. Go find the residual. Okay. All right. So I'm assuming they want us to. They're gonna ask us a graph. So.
They just want to know if it's in a linear thing.
Okay. And wait, let's see. So we put the residual in the y-axis, right? and confidence rating in the x-axis. Come on. Okay. It looks like there's no pattern.
I don't see a pattern in it.
That's a good thing.
Yeah. I know. So do we need to go make a linear for this, or
I did
I don't
linear.
know.
Of the unstandardized,
You what?
they're all close to the center.
Okay. Okay. So going back to our, you're fast, Chris. I'm just still floating around a little bit. Okay. So let's go back to the question. Question says, complete the residuals for using the data software. What statement best describes the residuals? They form a linear pattern. Residuals are all negative, or they're between -40 and 25. Okay.
I just put
None
they
of
form a
those.
linear pattern. I'm not looking at numbers.
Well, I'm looking at the negative. It said -40 and 25. I'm not sure that best. I don't like this question.
Well, I don't think it does them, because if you looked at the QQ plot, is that the one we're looking at? Of unstandardized residuals?
Let's
Because
see.
there's a plot up there that's clear up to 40, almost.
Is there?
And there's
Okay, so if you do the
-40 to 25. There's one up there that's a 40.
Huh. So when you do the QQ plot, you just put the residual in there, right? I
Right?
was trying to remember how to do it. All these different ways to do all these plots. Okay. So, yeah, it looks normal. So what do you guys want to answer? I don't know.
I put it as
Eduardo, are you linear? So B?
yes.
Yeah.
Don't quote me on it,
Okay.
but there was one that was up there way up at above 40 on the residual plot.
Uh-huh.
There's one that goes from -40 to 25, but there's like a couple of them that are up above 25.
Okay. All right. I'm good with that. Residuals form a linear pattern. Well, that actually makes sense, because if you think of, okay, now that my mind's trying to process, the first test that we're asked to run asks you to look if they're qualify for a linear, if they're linear. So
Yeah,
you look
is
at
there
this.
a linear relationship?
So you look at the scatter plot for hot dog shape, and then for no patterns, and that says it's linear. So I'm good with that. Okay, based on the QQ plot for these residuals, what can you say about these residuals? They look fairly normal to me, right?
Yes.
Okay, I'm with you. Let's see. Yep. There. I mean, there's a little curve on the line.
Not much, though. And I
No,
think
it
it's
follows the
probably
line
from
from
that
you guys.
outlier.
Yeah. All right. So B again.
And they're definitely not right skewed.
No. All right. Use software to create a scatter plot of the data. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Well, we already decided. Yeah.
The last two we can't
The
calculate.
We already said there's a linear relationship. And we also said, didn't we say they were normally distributed already?
Mm-hmm.
So.
But the last two, these are all the 5 tests, but the last two we can't calculate. So the plots aren't going to have anything to do with those. Right?
So then the question is, the variance of the error term is constant with all values of x.
That's what you get with your QQ.
Yeah, it's where they have constant variances.
That's your QQ plot of the residuals.
It's worded a lot different than they did with us, but I think it's, yeah.
It says that the plots of the QQ plot are close to the line.
Okay. Okay. All right. Okay, what is beta 1, the estimate for the slope? And we do that by the descriptives, right? Whoops. Nope. I need to run my.
I think it's by the.
It's the confidence.
It's the coefficients, isn't it?
Yeah. I'm just trying to double check, make sure. Second row. So the slope. So would it be 12.695? Is that our linear?
Well, and that's where my question was, because if you do.
You
There's
just go
another
run
one.
that linear. What was that?
Says I got a different answer, but I think it's because I ran the wrong one.
So I have it where you put score in the dependent box of the linear regression.
Right.
And then for block 1 of 1, you put confidence rating mean. And then hit OK. You can go actually up to the statistics box and click on confidence intervals. Just so if they ask us that question, we'll have them. But I got 12.695 for the, on my notes it says the second row gives the value, the slope
Gives the value of the slope. So
yeah.
it's 12.695.
Yeah, that's what I got. What did you just do, computer? Let's see, let's try that again. 12.695. Okay. And then 10, now construct a 95% confidence interval for beta 1. Put your answers
That's
for
the
lower and
beta
upper
1.
bound. Yeah, I think it's kind of the same. I hate to say it, but I think they always
get like
change it.
0.386 for a beta 1 answer, a lower bound and an upper bound.
What'd you get? I got 10.674. Yeah.
Okay.
I know it's very confusing, but they kind of did that with the other one.
So what did you guys get for number 9?
12.695.
Thank you.
Let's see. And then for 11, it would be 14.715.
So what was number 10?
10.674.
10.674. Thank you.
Chris, am I doing these right?
Well, probably. I got a different score when I did the beta one, but I don't remember what test I got it from. So it's probably not right.
So when you're running the beta, what I'm just trying to remember how they, like, if you changed anything.
Okay,
Yeah.
let me see.
So The way I understood it is when you ran the test, you actually ran it kind
So
of
you ran the test, you
similar.
ran it linear, right? You did analyze linear regression and then linear. And that's the test you ran.
Yeah.
Okay.
But so my question, let me go back to my thing. I think it gives you, like, there's no, like, they have residual statistics in here, but I don't think the residual really, I think beta is still as if we were running the other test for the coefficients.
Okay, so if you look into the coefficients, are we doing, which one? Are we just doing the crocodile one still? Or are we doing the other one?
The math one.
Right
Oh,
now
okay.
we're on the math.
All right.
And if we look at, so we look at the p-value, it's 0.000. So this thing's based on the evidence using the level of significance at 0.05. What decision would you make regarding the hypothesis test for beta 1?
We'd reject it.
Yeah.
Because it's
And
way
it would
above
be, well, it's 0, so
It's less than alpha.
Less than no.
C. Yeah, we reject no because its p-value is less than alpha.
Okay,
that
so
would be
this correlation coefficient R, where does that come into all of this?
the correlation coefficient. What? Sorry.
R, the R that we're finding. That was like 2 weeks ago.
Right. So the R. That's just the number that's used to measure the direction and strength of a linear association. So whether it was positive or weak and moderate.
Oh, okay.
It tells us.
That's where the R comes in. It has
Yeah.
nothing to do with this that we're working on now.
Yeah.
Okay.
And then you also use it when you're trying to find the covariance.
Right, because then you have to do it
Yeah.
times and then plus.
Yeah. R times standard deviation of X, standard deviation of Y. So.
Okay.
Okay. So for a hypothesis test for beta 1, if you reject the null hypothesis, what does it mean?
Well, it means,
it means, yeah, go ahead.
It means the slope's not 0.
Right. So it means there's a linear, what's the word I'm trying to say?
There's a linear relationship
something.
between X and Y.
Thank you. Yeah. So there's sufficient evidence to conclude that the slope of regression of line is not 0. So it'd be D. Because the null is that it is 0. So if we reject it, we're saying it's not 0.
Okay.
And now we go to the estuarine crocodile for the next 5 problems. Okay, for this data, which variable is the dependent variable? So you would tell that by saying which one is trying to be predicted.
That's the body length, isn't it?
Yep.
Yep.
Yeah. Yeah. Because that's the one that will be affected if you increase the head length. The body length will also increase. But if you increase the body length, doesn't mean the head length increase. That's how you can tell sometimes which one is being rejected or which one gets played on by the other. Okay. Now construct a 95 confidence interval beta 1. Input your answers for the margin of error, lower bound, and upper bound. Did we ever learn margin of error? I don't remember learning margin of error.
Not for this.
That's the one I don't know. The only margin of error I ever remember is 1.96 times the standard deviation over the square root of the
Right.
Well, that's it for
Right.
for 95. Oh, you're right.
Well, let me see. Let me see
But
if
I don't
run.
remember anything about it in this, and I've gone back over it and I can't find anything. And I don't know.
I
Okay,
wonder
well,
if we use it the same formula.
Well, you could, or let me
Is
see
there a
what this.
standard deviation or a standard of error in there?
Let me just play with this for a second. Okay, come on. Because it's a, what kind of a test does it run? It's a t-test, right? Oh, it doesn't like this when I did this. Okay. Okay, it's when you run it in a ANOVA test. Okay, let's try this again. Regression, linear. Okay, dependent was body length. Okay, head length goes into independent. I go to statistics, and I want the confidence intervals. How about some descriptives? Why not?
Why not?
Why not?
I couldn't figure it out. I don't know.
Keep it coming.
Okay, let's see what it says to me. Well, that's weird. Okay, it doesn't like what I'm doing to it.
It's all. If it had a
Yeah.
buzzer, it would be buzzing at you.
Yeah. Okay. Body length. I've got means and standard deviations. I've got
standard deviations.
got some correlations here. Here's the ANOVA test. And here's my coefficient test. But I don't see. Okay. Well, margin of error
Well,
is.
But you
Under-
have
Go
two
ahead.
margin of errors.
under the confidence intervals section, it talks about running a what did I just read it? 95% confidence. So we should be able to do some sort of.
Well, it gives us, in the residual statistics even, it gives us the numbers, 28, and it gives us the standard deviation if we're using the residual statistics.
Yeah. Well, also, let's see.
Losing ANOVA,
Mhm.
it doesn't give us a standard deviation.
It on descriptive statistics of head length, I have a standard deviation, I have means, and I have some standard deviation. So but we wanted to know what was for slope. Okay, but also, so if you have a lower bound and an upper bound, here we can put those in. I can tell you what the lower bound is if I know what I'm. If I'm
Okay, so
guessing.
I have a lower bound of 299.92.
Okay, let me get there. Yeah, let's see. Wait. See, I have a different lower bound.
Okay, so this is under descriptives.
Yeah, mine's under the coefficients.
Okay, so let me go down to coefficients.
But I'm not claiming that I actually know what I'm doing. To be honest, let's see. I have, yeah, I don't know. I have 7.218, but
That's what I have as well.
okay.
You have
Yeah.
7 point, what?
218.
Now, where are they coming from? The coefficients?
Yeah, when we ran the coefficient.
Oh,
And I know I'm feeling a little insecure about this quiz. But isn't the margin of error?
margin of error usually is 1.96 times the standard deviation over the square root of n. But I
Right.
don't know if we
There's
have
something
all
on top of that.
Well, but see, look at this. If you have the mean,
You should be able to figure it out.
right. So, for example,
So-
the mean.
Your lower
The
bound was
mean-
7.218. That's where you're looking at.
Yeah.
And then your
So
upper
if-
was 8.103.
Right. So let me try something. 8.103.
What was that that you
Minus-
figured out?
Here we go with back door again.
That one time where we just minused. Remember
you
that time
can-
that we had all that information and we just minused it and it was like the same answer and we were like, huh, that's pretty cool.
Right.
It's really good unless you got lots of crazy numbers.
Yeah. So do you minus it by the standard deviation? Let's see. Let me see this. Okay. Let's see. I don't know. Okay, hold on. I hate this when they do this. I mean, they never talked about this anywhere.
Never talked about a margin of error anywhere that I could see in these groups.
Talk about gap in information.
Right. All right, let me try something.
Oh yeah, they just kind of threw it in there, and I'm going, I have no idea where it goes.
Right.
And then I have to think, and I don't do that very well sometimes.
Well, we can try and go at it. So the t-score is 35.588 times the standard deviation, which, yeah. Okay, let me go up and
But
find
you've
it.
got two.
9.657 divided by 28. I really don't know what I'm doing, guys.
It's the square root of 28.
Yeah, square root of 28. Thank you. Okay. Let's see what I get just for fun. Okay, 9.657 divided by 291 times 35.588. Huh. Well, I got. See, I just don't know what I'm doing.
Well, I got a 0.442 if you take 7.660 and minus the 7.218. You get 0.442. I'm just going to see if that will add up to the other one.
Yeah, keep looking at. I'm gonna go. I'm gonna go see if I can find information in the chapter real fast.
0.442 equals. It does add up.
Okay, so you got 0.442.
0.442.
Okay, and how did you remind me how you got that?
Well, I took the t-score, or the
Okay.
b. I took the b
Uh-huh.
and subtracted the lower bound, and then I added what I got from that to the upper bound,
Oh,
or to the
okay.
7.660.
Okay. Awesome. Let's try it. I hate it, but let's try it.
I don't know what else I can do with it. I don't know where it goes, and I don't remember anything about it
Right.
in the.
Right.
Let me
Okay.
check my math again.
No, because I got that answer as well. Actually, I took the upper bound, minused it by the lower bound, and then divided it by 2, and I got 0.442.
You would think with all the statistics that we had that there would be some kind of a margin
There's
of
no
error.
standard.
Did you guys get 0.442 or 0.443? Because I got 0.442.
Well, I got 0.4425.
Right. So then
Well,
you
we'll make it 0.443.
right. Okay, cool. Just making sure.
Well, yeah. I hate the thought, but I'm just like, you know, when you're confident, you're thinking, "Hey, we did really good," and I know we're gonna ace this. This one, I'm not as confident. Let's just say that.
Yeah. This
Okay,
one's-
based on your Yeah. Based on your lower bound and upper bound from the last two problems, what can you say about B1? I think it's A.
Which one?
A, the first
How
one?
are we, which question are we at? 18?
18.
Oh, I'm sorry.
Sorry.
I totally
Yeah.
didn't write down what you guys said for the 15, 16, 17. Sorry.
Okay. So 15 is, you're fine. For 15, we put down 0.443.
0.443. Okay. And then the lower bound?
7.218.
7.218. Okay.
And then 8.103 is 17.
Thank you.
And for number 11, it was 14.745, right?
I think it was 715 for 11.
14.715?
14.715. Yeah.
Okay. Okay. I don't know what that's.
Okay, I'm gonna. Yeah.
Okay,
I'm
so
gonna
I think that last.
Should I submit it or
18?
no?
I think it's.
Go
I
ahead.
think you're right. I think it's A.
Okay. All right, I'm gonna submit it. Let's see what happened. All my hopes and dreams will be shot. No. Okay, so 6 was wrong. That was that question about the residuals form a linear pattern. That was that question I hated because I thought it was pathetic. Let's see. Seriously, if that's the only one we hey, we got the margin. That's the only one we missed. Hey, that's pretty good.
So then the residuals, question number 6, they're looking at it's between 0.40 and 25, and they're just blowing out that last outlier that's there.
Well, let me.
I think it's the residual is between negative 40 and 25. I'm pretty sure.
Does somebody
All right.
want to change
Put it in
theirs?
there and submit
I'll
it.
do it. So I changed
that-
it to the negative. That's correct.
Okay, so it's
Well, I'll
which
be
answer?
dang.
Oh, wait a minute. I have something else wrong.
You do? So
maybe
wait,
I-
which one was
Hold on.
6? You
Oh.
said that.
Oh, I got
The
number 8
residuals are-
wrong. Which ones
Okay.
did you guys mark? It's that one where it
Uh,
check all apply.
the top
It's
3.
the first 3.
Oh, see that's me. Okay, then we're fine. I'll just change those myself.
Okay, so wait, number 6, we picked the residuals are between negative 40 and 25.
Correct, ma'am.
Is that what? Okay.
And wait, so number 8 was just the first 3?
Yep.
Yeah, 1, 2, and 3.
Okay.
Yeah.
Yay.
Okay, I don't
Okay,
like
so
that
now-
answer
Yeah.
on
that's dumb.
6. I don't like that. Oh well. Okay, I quit.
Okay, but now you know the margin of error. How to find it? You can
No,
either.
I went through the back door.
Right.
Back
Well,
door
that's
to
how I
go.
went too. Yeah. Well, that's what I'm saying is sometimes that's what you. Let's see. Okay. But yeah, when they ask you to write to do a test for beta, which is the true unknown population, you just run it the normal. You go find the confidence. Hey, yeah. How did I do that? Anyway. So you just run the linear regression, linear, and then put the dependent variable in the x-axis, the independent one in the whatever axis, and run it. And then you go to the coefficients for those answers.
Okay, so when you do you do descriptive on all of them?
Not usually, because it really doesn't give you the descriptors are too confusing.
Okay.
And so
the
they,
descriptives are really only used on the Z and T.
yeah, right. I mean, what I understood from this lesson, where to find all those descriptives that we want. So it said the relevant statistics that you want are the sample size, which you can get from, sorry, I'm just going to go back to my thing. You can get the sample size from actually all those areas. The ANOVA test, if you add, you know, the total up, it's your sample size. Or you can get it from the residual statistics. That gives you sample size.
Yeah.
And also then they want to know what the estimated regression equation is. So that's the y hat equals the little b naught plus b1 times x. That's, so those are the, so you run those, whatever, regression linear, and that gives you the coefficients. So then you've got your B naught would be 18.690, or sorry, I'm giving you a number, but it doesn't make sense.
Right.
Okay. It would be that top one under B, and then
Y would be the second one.
yeah,
That would be the 12.695.
So those are the relevant statistics for this test. And then the test statistic you find in that coefficient table on the bottom line.
Right.
The degrees of freedom you find up in the ANOVA table on the residual row. And then the p-values back under that coefficient line on the bottom line. So that's how it said where to find all of these numbers that you need. Now, it never talked about a margin of error. So, but that you just, all you have to do is take the upper bound, minus it by the lower bound, and divide it by 2. And that gives you your margin of error. So.
Or you can take the lower bound, or you take the B and minus the lower bound, and then add that what you get to the B and see if it'll get you the upper bound.
Okay. Yeah. You're talking about the on the bottom right. Number, so it's the slope. So take the slope, minus
take
it by either the upper or lower bound.
And then take whatever answer you get there and add it to the slope, and it should give you the upper bound.